Welcome to Lesson 33, Finding the Probability of Independent Events. Please take a look at the box at the top of your notes, or the table that talks about the two different kinds of events for probability. We can have independent events, and the definition of that is that the outcome of the first event does not affect the second event. So the probability of each one are independent of each other. They do not depend on each other. And when you're trying to calculate probability of the two happening together, you just multiply their two separate probabilities. For two events that are dependent, which means the outcome of the second one depends on what happens with the first event, you multiply the probability of the first event times the probability of the second event calculated under the new conditions according to what happened in the first event. So let's look at a couple examples here and identify whether they're independent or dependent. So tossing two coins, a dime and a quarter, to determine heads or tails. Now, tossing one coin to determine heads or tails is not going to affect whether the other coin lands on heads or tails. So those two events would be independent. They do not depend on each other. The next one, tossing the same coin twice. Contrary to what some people believe, if you toss a coin, heads or tails, it's 50-50 chance. Toss it again, it's still a 50-50 chance. Every time you toss it, it's 50-50 chance, no matter what it landed on the time before. So the second time you toss is independent on the first time you toss. It's not going to change what happens the second time you toss. Okay, the next example, if you put 10 students' names in a bag and you draw two names without replacement. So what that means is you draw out the first name and you keep it out, and then you draw another name. So this one, the second event, the second name drawn, does depend on what happens the first name drawn, because now the odds or the probability have changed for the second name being drawn because there are less names in the basket at this point because you already took one out and you kept it out. Okay, the last one is if you put 10 students' names in a bag and you draw one name per week to choose a room monitor, and a student can be chosen more than once. That means you are putting their name back in the bag each week. This would be independent because it's the same number of names in the bag each time, and it doesn't have anything to do with what name was drawn the previous time. Moving on to the next example, a coin is flipped twice. Make a tree diagram showing all the possible outcomes. What is the probability of the coin landing on heads and then tails? So heads and then tails is what we're looking for. We write probability as function notation. So we have the probability of heads and then tails is what we're looking for. So to draw a tree diagram, we can start with labeling. This first column is going to be the first flip. So the first flip, we can either have heads or tails. Those are the two possible outcomes. And for the second flip, if we draw heads the first time, we could draw heads again, or tails. For tails, we could draw tails again, or heads. So our possible outcomes here are heads, 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 tails, 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 or tails, heads. So what is the probability of flipping heads, tails? There are only one possibility for that out of a total of 1, 2, 3, 4 possible outcomes. So the probability would be 1/4. Okay, let's look at a few other examples here. A bag has 5 $10 bills and 15 $1 bills. Find the probability of drawing a $1 bill, keeping it, and then drawing a $10 bill. So these would be dependent events. because we're keeping one of the bills out the second time we draw. We're not replacing it. So the probability of choosing a $1 bill the first time, there are 15 $1 bills out of 20 bills altogether, because there's 15 plus 5. So that's the probability of the first event. The probability of the second event is drawing a $10 bill now. Now, supposedly, if this went the way it was supposed to, we would have drawn out a $1 bill. So there are still 5 $10 bills in the bag. However, there are now 1 less bills in the bag, so there's not 20 anymore, there's only 19. So to find the probability of these two things happening in a row, we multiply their two probabilities together. So we can cross cancel here. 5 goes into 5 once, and 5 goes into 20 4 times. So we have 15 times 1, which is 15, and 4 times 19, which is 76. So the probability of these two things happening together is 15 out of 76. Now the next one here, the probability of drawing a $10 bill, keeping it, and drawing another $10 bill. So the first event, the probability of drawing a $10 bill is 5 out of 20, because there's 5 $10 bills out of 20 bills. And then the second event, now there's only 19 bills because we kept the $10 bill that we drew out first. But now supposedly there are only 4 $10 bills left because we already drew one. So we'll multiply these. You can cross cancel. 4 divided by 4 is 1. 20 divided by 4 is 5. And then 5 over 5 would be 1. So this is equal to 1/19 is the probability of that happening. Okay, moving on to the next example. A box contains 3 pink, 4 yellow, and 5 blue highlighters. One highlighter is chosen at random. What are the odds? And I want you to go back to the first page of your notes briefly here. And it has a little hint here of what odds are. Just to remind you, odds is a ratio expressing the likelihood of an event. So we're going to go back to our example here. Remember, a ratio is usually written as a fraction or a number with two numbers with a colon between them. So what are the odds of choosing a yellow? So yellow, there's 4 options for yellow. So that's 4. That's what we want. 2, what are the options that are not yellow? Pink and blue. So we have 3 and 5. So we have 3 plus 5 here. So the odds are 4 to 8, which can be written as 4 to 8 like this, or 4 to 8 like this, and that can also be reduced. So it would be reduced to 1/2 or 1 to 2. So the odds of choosing a yellow highlighter are 1 to 2. What are the odds against choosing blue? So now we're going to go back and look at these again here. So against blue would be everything that's not blue, so yellow and pink. So that would be 3 plus 4. That's the odds against blue. And then the number that is blue would be 5. So 3 plus 4, is 7 to 5. So we can write it as the fraction or write it with the colon, 7 to 5. So those are the odds against choosing blue. Okay, our last example here. A computer club has 10 boys and 12 girls. The chess club has 15 boys and 5 girls. Each club will choose a member at random to be club treasurer. What is the probability that both treasurers will be girls? Now these events are independent events because they don't depend on each other. if a girl is chosen in the chess club, that has no effect on whether or not a girl is chosen in the computer club. So let's look at the odds for the computer club. There's 12 girls, so the probability is 12 out of however many total people there are, which is 10 plus 12, so 22. So those are the odds for the computer club. And then the odds for the chess club are 5 girls out of 5 plus 15, which is 20 total people. So now we just need to multiply these. And we can do some cross-canceling here. So 5 goes into 5 once, and it goes into 24 times. And then we can also cross-cancel with the 12 here. So 4 goes into 4 once, and it goes into 12 3 times. So now we have 3 times 1 on the top, which is 3, and 22 times 1 on the bottom, so 22. So the probability that both would choose girls for members at random is 3 out of 22. Now, both girls have resigned and a different pair of students is chosen. What is the probability that both will again be girls? So now, for the computer club, now there are only 11 girls left because one girl resigned, and there are only 21 people. And in the chess club, there are only 4 girls left, and there are 19 people. So there's nothing really to cross-cancel here. We just need to multiply. 11 times 4 is 44, and 21 times 19 is 399. And there's no way we can really reduce this. So the probability is 44 out of 399. And that is today's lesson. Thank you for taking notes and listening.